Notation for sets introduction. So let's begin our discussion on sets. Welcome to this tutorial on set notation. As we start, it's important to understand that in mathematics, a set, and I'll be saying that word a lot, is a really basic, fundamental idea. Think of a set as simply a collection of things. But these aren't just any things, they have to be distinct, meaning each object in the collection is unique. Now, just like any language, mathematics needs its own way of communicating ideas clearly. When we talk about these collections, these sets, we need specific notations or symbols to represent them. It's like learning the alphabet for a new mathematical topic. Over the course of this tutorial, we're going to walk through the standard, accepted way to write down sets and to refer to the individual items within those sets. We'll cover everything you need to know to confidently work with sets in your future math studies. We'll start with how we name sets, then move on to how we list what's inside them. So, let's get started. Denoting sets. This slide explains the standard notation we use for sets. It states that sets are conventionally denoted. That means represented by capital letters. You'll often see sets named using letters like A, B, C, X, and Y. Think of it like giving a set a label. Instead of saying, the set containing the numbers 1, 2, and 3 every single time, we can simply refer to it as set A. And the reason we do this is to make our mathematical communication much easier and more concise. It avoids us having to write out all the elements of the set repeatedly. So we've talked about what sets are, collections of distinct objects. Now, let's discuss how we write them down mathematically. We'll see how this works in the examples coming up, where we'll actually create some sets using these capital letters and curly braces, which we'll cover on the next slide. So remember, capital letters are our shorthand for referring to sets. Elements of a set. Now, this slide tells us that the individual objects within a set are called either elements or members. These terms are interchangeable, so you can use whichever you prefer. Think of it like the individual pieces that make up the whole collection. And here's a really important point. These elements aren't limited to just numbers. They can be absolutely anything. They can be numbers like 1, 2, 3, or even decimals and fractions. They can be letters like a B, C. We saw an example of that on the previous slide with the vowels. They can even be shapes like circles, squares, and triangles, as we'll see in a later example. In fact, elements can even be other sets. That might sound a little strange right now, but it's a powerful concept we'll explore more as we get further into set theory. The key thing to remember is that as long as it's a well-defined object, it can be an element of a set. So let's move on to understanding what actually goes inside these sets we've been talking about. As we saw on the previous slides, we use capital letters to name the set and curly braces to contain its contents. So just keep in mind that sets are incredibly versatile and can contain a wide variety of things. We'll see this illustrated in the examples coming up, where we'll build sets with different types of elements. Using curly braces. This slide explains that we enclose the elements of a set within what we call curly braces. These look like this. Think of them as special brackets just for sets. Why curly braces? Well, this is really important. It visually distinguishes a set from other mathematical expressions you'll encounter. You'll use regular parentheses or brackets for different things, so using curly braces immediately tells anyone reading your work, this is a set. Finally, the elements, those individual items within the set, are separated by commas. So, if we were listing the numbers 1, 2, and 3 in a set, we wouldn't write 123. Instead, we'd write 1, 2, 3 inside the curly braces. So now we're moving on to how we actually write out a set. As we discussed on the previous slides, a set is just a collection of things, and we use capital letters to name those collections. But how do we list what's inside the set? This will become very clear when we look at some examples on the next few slides, where we'll actually build some sets step by step. Remember, curly braces and commas are the key to correctly writing out a set. Example 1, set with integers. Let's move on to our first example of actually creating a set. As we discussed in the previous slides, sets are collections of distinct objects, and we use capital letters to name them. So this slide asks us to create a set containing the first 3 positive integers. Remember, positive integers are whole numbers greater than 0, 1, 2, 3, and so on. We're going to denote or represent this set as a equals an opening curly brace, 1, 2, 3, and a closing curly brace. Notice how we're using those curly braces. That's crucial for defining a set, as we learned on the last slide. This mathematical statement, a equals an opening curly brace, 1, 2, 3, and a closing curly brace, is read as set A contains the elements 1, 2, and 3. Now let's break down how we built this set, step by step. First, we chose a capital letter. In this case, we chose A to be the name of our set. It could have been B, C, or any other capital letter, but O is convenient for our example. Second, we opened the curly braces. These braces are what visually tell us that we're defining a set. Third, we listed the elements. The elements are the individual items that belong to the set. Here, those elements are the numbers 1, 2, and 3. And importantly, we separated them with commas. Each comma tells us we're moving on to the next distinct element. Finally, we closed the curly braces. Just like with parentheses, every opening brace needs a corresponding closing brace to properly define the set. Keep this example in mind, as we'll be building on this concept with more complex sets in the following slides. Remember the key components: a capital letter for the set's name, curly braces to enclose the elements, and commas to separate those elements. Example 2, set of vowels. Let's move on to another example. As we've discussed, sets are a way to group distinct objects, and we use capital letters and curly braces to define them. This slide asks us to create a set containing the vowels of the English alphabet. Remember, vowels are those letters, E, I, O, and U. So we'll denote this set as V equals curly brace, a comma, E, comma, I, comma, O, comma, U, curly brace. Notice how we're using a capital V to represent our set, just like we did with A in the previous example. Let's break this down step by step. First, we choose a capital letter to name our set. In this case, we've chosen V. It's simply a label to help us refer to this specific collection of vowels. Next, we open curly braces. These curly braces, as we've learned, are essential for defining a set. They tell us that everything inside them belongs to the set. Then we list the elements. Here, the elements are the vowels, E, I, O, and U. We separate each vowel with a comma. This comma is crucial. It tells us that each item is a distinct element within the set. Finally, we close curly braces. This completes the definition of our set. So, V represents the set containing the vowels E, I, O, and U. Keep in mind what we'll cover on the next slide. The order of elements doesn't matter in a set, and we don't repeat any elements. But for now, this example should solidify your understanding of how to denote a set with its elements. Example 3, set of shapes. Let's move on to another example. This slide shows us that the elements of a set don't have to be numbers. Here we have a set, denoted by the capital letter S. It contains different shapes, and we write it as equals open curly brace, circle, comma, square, comma, triangle, close curly brace. So, we're listing the elements, circle, square, and triangle, inside the curly braces, separated by commas, just like we've practiced. Now, the important thing to notice here is that the elements can be words or phrases, as long as those words or phrases clearly define a specific object or concept. In this case, circle, square, and triangle are all well-defined shapes, so they are perfectly valid elements of a set. Remember from the previous examples, we used numbers and letters. Now we're expanding that to include descriptive terms. This shows the flexibility of sets. They can contain pretty much anything you can clearly identify. Keep this in mind as we move forward, because in the next slide, we'll be summarizing the key takeaways and also looking at some common mistakes students make when working with set notation. So, It's important to solidify your understanding of how to correctly represent sets with different types of elements. Key takeaways. Let's recap what we've learned about set notation with these key takeaways. First, remember that we always represent sets using capital letters. As we discussed earlier, things like A, B, C, X, or Y are commonly used to name a set. It just makes things cleaner and easier to work with. Next, and this is crucial, the elements that belong inside a set are always enclosed within curly braces. Think of them as the boundaries of the set. So, we write them like this: open curly brace, list the elements, and then close curly brace. And within those curly braces, we separate each individual element with a comma. This tells us that each item listed is a distinct member of the set. Now, here's a concept that students sometimes find a little tricky. The order in which you list the elements doesn't matter at all. A set containing 1, 2, and 3, that is, 1, 2, 3 within curly braces, is considered identical to a set containing 3, 1, and 2, also within curly braces. Sets are about membership, not about the sequence of elements. Finally, and this is another important rule, each element can only appear once within a set. Sets only contain unique values. If you accidentally list the same element multiple times, it's still only counted as a single member of the set. We don't allow duplicates. Keep these points in mind, and you'll be well on your way to confidently working with sets. In the next slide, we'll look at some common mistakes students make when dealing with set notation, so we can avoid those pitfalls. Common mistakes. So the first point here is about using the correct brackets. It says, using square brackets or parentheses. Remember to always use curly braces to define a set. Now, you might be used to seeing square brackets or parentheses in other areas of math, and it's easy to get them mixed up. But when we're talking about sets, we specifically use curly braces. So, instead of writing something like elements inside square brackets or parentheses, always use curly braces. That's the universal signal that you're defining a set. Next, we have forgetting commas. Commas are essential to separate the elements within a set. Think of commas as the breath between each item in your set. They tell us where one element ends and the next begins. Without them, it becomes difficult to interpret what you mean. For example, if you wrote 123 inside curly braces, it could be read as the number 123, rather than the set containing the numbers 1, 2, and 3. Moving on, including duplicates, sets only contain unique elements. If you list the same element multiple times, it is still considered only one element in the set. This is a really important concept. A set is about distinct objects. So, if you write something like 1, 2, 2, 3, it's the same set as 1, 2, 3. The repeated 2 doesn't change the set. It only contains one instance of each element. Finally, confusing sets with lists. While both involve collections of items, sets are unordered and contain no duplicates, while lists are ordered and can contain duplicates. This is where things can get tricky. Both sets and lists are ways to group things together, but they have key differences. In a set, the order you write the elements doesn't matter. 1, 2, 3 is the same as 3, 1, 2. Also, as we just discussed, sets don't allow duplicates. Lists, on the other hand, do care about order, and they can have repeated items. So remember, sets are about unique membership, while lists are about sequence and potentially repeated entries. Let's move on to the final slide, which highlights some common mistakes students often make when working with sets. Understanding these pitfalls will really solidify your grasp of the notation. Alright, that covers all the key points about set notation. Hopefully, this tutorial has given you a solid foundation for working with sets in your future math studies. Remember to practice using the correct notation, and you'll be well on your way to mastering this fundamental concept.